So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we are gonna be proving the Kummer series. Basically, it's a series that represents natural logarithm of gamma function, right? And obviously one of my subscriber asked me to prove this down, so here I am with. So basically, this thing what we're gonna prove in this video, and this is like, this looks pretty crazy, but it's not that much difficult to prove, I would say. But you need specific tools to prove this down, and if you are ready with the tools, you are good to go with the proof. It's easy. So we have tools, right? So let me just show you the tools, and then we'll just talk about the proof as well. So the tools, the first one is Ledge theorem. This is the only thing that I haven't proved yet, but maybe I'm just gonna prove this down in future. But I think I have to prove this down because my philosophy says, if you haven't proved something, you are uh, illegal to teach that down. But it's all right, I'll just make a video on that, don't worry. So we have the derivative of the Hurwitz zeta function evaluated at s equals 0 as natural logarithm of gamma function minus 1 over 2 times natural logarithm of 2 pi. So yeah, that's quite amazing thing. I have tried to prove this down, but unfortunately it's quite difficult, I would say. But it's all right, I'll prove that down. So this is a page of my YouTube channel. So the second tool is the functional equation of the Hurwitz zeta function, and I have proved this down. I took 30 minutes. So you just need, these things are the prerequisites actually. But I'm not gonna say this is the only, because I haven't proved that yet. But these things are the prerequisites actually. This one is also, and this is the cosine identity, and this is the sine identity, which we are gonna use in this video, in the proof of this video. So yeah, these are the tools that we are gonna play with, and we'll reach up to this value. So let's just get back to the proof. So yeah, here's the proof. The Kummer's natural logarithm of gamma functions formula. So this is the one which we are going to prove in this video. 1 over 2 minus x times Euler-Mascheroni plus natural logarithm of 2 pi plus 1 over 2 times natural logarithm of pi over sine pi x, and plus 1 over pi times the infinite sum as n goes from 1 to infinity of natural logarithm of n over n times sine of 2n pi x. Yeah, so this is the Kummer series. So basically here comes the proof. So basically we're just gonna begin our proof with Hurwitz zeta function. I know this spelling is wrong, but I'm sorry about that, don't worry. So we have this is the Hurwitz zeta function, right? And as I just explained you, the Ledge theorem. So basically it's the derivative of the Hurwitz zeta function evaluated at s equals 0 gives natural logarithm of gamma function minus 1 over 2 natural logarithm of 2 pi, right? And if we isolate here the natural logarithm of the gamma function, so we're gonna have natural logarithm of gamma function equals 1 over 2 times natural logarithm of 2 pi plus the, actually I just messed up the derivative, that is this one. Yeah, so the derivative of the Hurwitz zeta function of 0s, basically s equals 0 here, right? So now we have the functional equation of Hurwitz zeta function. We have proved that down. So basically the Hurwitz zeta function can also be represented as 2 times gamma of 1 minus s over 2 pi whole to the 1 minus s times sine of pi s over 2 times the infinite sum as n goes from 1 to infinity of cosine of 2 pi nx or 2n pi x over n to the 1 minus s plus cosine of pi s over 2 times the sum as n goes from 1 to infinity sine of 2n pi x over n to the 1 minus s, right? Yeah, now let's assume it as, let's just talk about this. So basically we have three different functions, I would say, these three functions, the first one, the second one, and the third one. So we're just gonna represent this one with a of s basically, and this one with b of s, and this one with c of s. Basically it's quite complicated to write them down like repetitive time. So in order to just get rid of that, we had just represented it as some sort of like that. So a of s is there, and b of s is something sort of here, and c of s as well. Right, now using the product rule, the derivative of this equation, actually this one, at s equals 0. So this is the derivative looks like, and we're just gonna use the chain not yeah, I think it's just product rule. I'm sorry, not chain rule but product rule. So taking the derivative of the first function, you know what, we can consider this as the first function, and this sum as the second function. So the derivative of the first times the second as it is, and then plus the derivative of this one and first is as it is, right? So here comes the derivative of a and the second as it is, and the derivative of second and the first as it is, right? So yeah, now we're just gonna talk about like, look, you know what, we have to talk about the derivative of all these functions, right? And that too at s equals 0. And then we have to evaluate for the function like a of 0, c of 0, and b of 0 as well. So if we talk about a of 0, so basically we're having a of s something sort of this, right? So if we talk about natural logarithm of this equation, so that's going to give us natural logarithm of 2 plus natural logarithm of gamma of 1 minus s, and minus 1 minus s times natural logarithm of 2 pi. And if we talk about the derivative of this equation, so it's gonna be a dash of 0 over a of 0 equals, and you know what, if you plug 0 here in this equation, so you're gonna have 2 times gamma of 1 over 2 pi, right? And it's 1 minus 0. So basically it's 2 over 2 pi, which is 1 over pi. So here it is, right? And yeah, we are having a dash of 0 over a of 0 equals like minus, basically like we have to take the chain rule here actually. And so for this one, if we are, because we are talking about the derivative, so that's gonna be negative, right? -1, so that's gonna be a positive overall here. So basically it's plus of ln 2 pi, and this is gonna be a negative because the sign is gonna change, because this is 1 minus s, neither 1 minus s minus 1, right? So yeah, okay. And we are having gamma dash of 1 over gamma of 1, right? And we are having plus natural logarithm of 2 pi. Now we know that Euler-Mascheroni, like the definition of Euler-Mascheroni's constant is negative the derivative of the gamma function evaluated at 1. So we can replace it with that. So basically we are having a dash of 0, and a of 0 is 1 over pi, so you can just substitute over there. So it's a dash of 0 is 1 over pi times this Euler-Mascheroni, this is Euler-Mascheroni, and plus natural logarithm of 2 pi. So here it comes your first part. So you are having a of 0 and a dash of 0 as well. Now let's talk about b of 0. So b of 0 is 0. Let's talk about b. So basically when you plug 0 here, so sine of 0 is 0, but means everything is 0, right? So yeah, and now if we talk about the derivative of b part, which is b dash s, so that's gonna be like, we're just gonna use this chain rule, I'm sorry, the product rule. Oh, I'm just gonna messing up with chain rule and product rule, but don't get confused guys. Actually the product rule is when two functions are being multiplied to each other and we have to take the derivative of this one. But the chain rule is you are having a function, and inside that you are having another function, let's say natural logarithm of 1 plus x square. So that's gonna be x over, actually 2x over 1 plus x square. So I think yeah, that's cool. Okay, I'm not sure, but it's all right. There's a lot difference between chain rule and product rule. So basically we are going to use the product rule here because you are having the first function and the second function, right? And this is your second function and this is your first function. So if we talk about the derivative of this one, so with the chain rule you are having pi over 2 factor, and it's cosine of pi s over 2. and the second function as it is. Just take a look at this. Here it is, right? And now for the second one, the first function as it is and the derivative of the second function with respect to s. So basically we do need to take the derivative of this function, because eventually when you plug s equals 0, so sine of 0 is gonna be 0, because hence this part is 0, right? So basically we're having pi of 2, and cosine of 0 is 1. So we are having pi of 2 pi over 2 times this sum as n goes from 1 to infinity of cosine of 2 pi nx over n. Basically s equals 0, right? Okay, so you're having b of 0 and b dash of 0 as well, and this part is 0. Okay, now let's talk about c of 0. So basically c of 0 is gonna be, let's talk about c. So when you plug 0 here, so that's gonna be cosine of 0, which is 1. So 1 times this infinite sum, right? Okay, and look, this is also like 0, so that's gonna be sine of 2 pi nx over n. So don't just forget about that as well. So here you are having c of 0, and now if we talk about the derivative of 1 over n to the 1 minus s, because we are having here we have to take care about this, because this term is not gonna vanish in this if you talk about the derivative of this one. So we have to take the derivative of this as well. So basically that's gonna be we can write this as 1 over n times the partial derivative of n to the s, right? Because 1 over n to the negative s is gonna be n to the s. So if we talk about the derivative with respect to s, so that's gonna be natural logarithm of n times n to the s over n. So basically it's natural logarithm of n over n to the 1 minus s, right? So here we did that. And now if we talk about the derivative, so it's gonna be the derivative of cosine is minus sine, and with a factor of pi over 2 with the chain rule, and the second function as it is. And if we talk about the first function as it is, and this the derivative of the second function, which came out to be natural logarithm of n over n to the 1 minus s, right? So basically when s equals 0, sine of 0 is 0, so this part is going to be 0, and we would be just having the second part. So yeah, and that too, this is going to be 1. Cosine of 0 is 1, right? So c dash of 0 is coming out to be this sum. This sum as n goes from 1 to infinity of natural logarithm of n times sine of 2 pi nx over n. And now let's just substitute back all these things like c dash of 0, c of 0, b dash of 0, b of 0, a dash of 0, and a of 0 back into this equation which we had assumed earlier. This equation, actually the derivative of this one, this equation, actually this one, and yeah, hence we are having some good things. So basically let's just substitute back. So this was your a dash of 0, right? Just remember that this was your a dash of 0. Here it is. So yeah, so here your a dash of 0 and times the b of 0 was 0 and c of 0 was this part, and times times wait a second, I think I just forget the plus sign here. I think yeah, now it's good. And it's 1 over 2 times pi over 2, and the derivative of the b of, so let's just talk about that. So it's pi over 2 times this sum. So yeah, the derivative of b part, so this is, and the derivative of this c part is this one. So now yeah, we're just getting rid of this pi, and we are having a 1 over pi factor as well, and here we are having 1 over 2. So basically the derivative of the Hurwitz zeta of 0 comma s is coming out to be 1 over pi times Euler-Mascheroni plus natural logarithm of 2 pi times the sum as n goes from 1 to infinity of sine of 2 pi nx over n, and plus 1 over 2 times the sum as n goes from 1 to infinity of cosine of 2 pi nx over n, like this one and this one, and plus 1 over pi, this factor, this part, it's natural the sum as n goes from 1 to infinity of natural logarithm of n sine of 2 pi nx over n. And now as I just explained, as I just mentioned you here, guys, just take a look at this part. The sum as n goes from 1 to infinity of cosine of 2 pi nx over n is coming out to be natural logarithm of 1 over 2 sine pi x. And that another, we are having another for this sum as n goes from 1 to infinity of sine of 2 pi nx over n is pi times 1 over 2 minus x. So I would request you to just watch that video, watch these three videos actually, because they are the prerequisites. So using the sign identity sawtooth wave, basically it's often known as, so this sum as n goes from 1 to infinity of sine of 2 pi nx over n is pi times 1 over 2 minus s. And so for the cosine identity, we are having log sine expansion, you can say. It's natural logarithm of 1 over 2 sine pi x, and this is the value for, like, this is the part which value is this is coming out to be actually. So we have talked about the proof of these two identities, this one and this one, so you can consider watch those two videos, right? And so for the functional equation, because that's amazing, that's interesting, I would say. So the sum as n goes from 1 to infinity of cosine of 2 pi nx over n is natural logarithm of 1 over 2 sine pi x. Here it is. And now substituting these two equations is in Hurwitz zeta of 0 comma s. So this is 1 over pi times the Euler-Mascheroni plus natural logarithm of 2 pi times the pi of 1 over 2 minus x. Here it is, just take a look at this. So this part is pi times 1 over 2 minus s, and this part is 1 over 2 natural logarithm of 1 over 2 sine pi x. Yep. Okay, so here it is. So basically you did substituted here and you did substituted the here as well. So and this part is as it is, we don't need to just bother this one, because this is in our final result, as like you might noticed. So we can write this as since pi and pi we are getting rid of, so it's 1 over 2 minus x times the Euler-Mascheroni plus natural logarithm of 2 pi and plus 1 over 2 times natural logarithm of 1 over 2 sine pi x plus 1 over pi, this sum as n goes from 1 to infinity of natural logarithm of n over n and times sine of 2 pi nx. Okay, and from the Let's theorem, as I explained you in the beginning of this video, so we can say the natural logarithm of gamma of x equals 1 over 2 like half natural logarithm of 2 pi plus the derivative of the Hurwitz zeta function of 0 comma x actually. So now we can just plug this back here and this part actually here, and let's just talk about the result. So basically natural logarithm of gamma of x is coming out to be 1 over 2 times natural logarithm of 2 pi as we had earlier here, and we are having this part actually. So this big part is of the derivative of the Hurwitz zeta function. So it's 1 over 2 minus x times the Euler-Mascheroni plus natural logarithm of 2 pi plus 1 over 2 times natural logarithm of 1 over 2 sine pi x and plus 1 over pi times the sum as n goes from 1 to infinity of natural logarithm of n over n sine of 2 pi nx. And now we can combine this term and this term, because we are having a factor of 1 over 2 actually, and we can just combine them after multiplying the arguments of those things. So basically it's coming out to be 1 over 2 natural logarithm of 2 pi over 2 sine pi x, right? So we are just getting rid of the 2's and we are having 1 over 2 natural logarithm of pi sine pi x, and we are done with the final result. So it's coming out to be natural logarithm of the gamma function is 1 over 2 minus x times the Euler-Mascheroni plus natural logarithm of 2 pi plus 1 over 2 natural logarithm of pi over sine pi x and plus 1 over pi this times the sum as n goes from 1 to infinity of natural logarithm of n over n times sine of 2 pi nx. So yeah, this is the proof of the Kummer series, and that was amazing actually, guys. But the thing that I'm feeling sad for, that we haven't talked about the proof of this one. Yeah, So I think I'm just gonna bring videos over there, but don't worry about that. I'm just working on that, right? So yeah, I think it was crazy, it was amazing, and love to just I love to prove this down. So I think I should just take leave now, and yeah, it's fine. Okay, so yeah, goodbye guys, take care, love you, and I hope you got to learn something out of this video. Obviously you did, because we did a lot of things. Like, we didn't do this thing only, we have done these three videos in order to prove that one, although we are left with this one as well, but it's all right. um, Mathematician dude, so we can just trust over that guy, but maybe it's not in our zone, but still I'm just working to prove this down. So I'm just gonna consider just plugging these four videos, including this video, and these three videos inside a playlist of named titled Kummer series proof. So yeah, this is amazing. So yeah, and if you have any kind of doubt so far, you are free to ask me in the comment section. I'll be there to reply over your questions. And goodbye guys, take care, love you, and just stay tuned for the next videos, because another videos, crazy videos like this are coming on the way. Okay, goodbye guys, love you.